continue. All right, so if you can see my screen, so the agenda for today's class is about the BGP, and I was telling about when to use BGP in any network. As we know that our IGP routing protocol is something which is used in a one autonomous system, maybe about something like a one company or maybe in some environment which is basically controlled by a one autonomous body. So our IGP protocol is something like that, like our RIP routing protocol, EIGRP, our OSPF, and ISIS routing protocol. These are the protocol which is used inside the any autonomous system. And your BGP is totally different from that. BGP routing protocol is basically the EGP, Exterior Gateway Protocol. Means it is used between that autonomous systems. Like the most popular use case of BGP is your between the ISPs. ISPs are running or connected to each other only with the help of BGP routing protocol. They're not using any other routing protocol. So the first use case you will see that BGP is used between the ISPs. Between ISPs it is going to be used. Something like a two ISP, maybe the national, international, or the state level. ISPs are going to connect it to each other with the help of BGP. Second use case, you may see that not going to use when any company, suppose company ABC, if we having more than one way to go to the outside world. Outside world means to connect on the internet. In that case, you are using a multi-homing concept. Multi-homing simply do not go in that depth. What is that multi-homing? Simply understand that multi-homing means when you have a more than one way to reach on the outside world, whether on the internet or whether on any network. If suppose there is a one company having the more than one way to connect to the outside world, in that case, we should also use the BGP. If only I'm going to use a traffic engineering. If I'm not using traffic engineering at all, so it's even not required to run that BGP there. The third use case for a company, suppose ABC, having many sites, branches. Like if I take example of a bank, there is a one big bank having the head office and there are many branches all over the country. So if you want to have your own connectivity between their branches, a private network doesn't mean that you are going to lay your own cable, which will not be allowed by any government body. It required a license. Then only you can lay the cable, dig the road and all that things. So if any bank, which is basically involved with the banking services, not with your networking and all that stuff. So what is the best option for the bank? Obviously to take a subscription from any ISP and to connect all the branches as well as the head office with that ISP service provider. And service provider is going to provide you the connectivity between that branches as well as the head office. And they will always feel that they are directly connected to each other. In that case also, we are going to configure our BGP, which is called as the VPN services, or we also call it as a leased line connectivity, a private network for any company. It's not just the example for the bank only, it may be for many other things. So apart from these three conditions, running between the BGP, between the ISPs, running BGP in the case when a company having more than one way to go outside and connect to the rest world. And the third, when you have something like a private MPLS BGP kind of a VPN connection. Apart from that three reasons, it is never recommended to configure BGP in your internal network or between any two customers. It is never recommended. It's totally useless concept. If you are configuring unnecessary BGP in your internal network and you are not aware about that, whether it is a good thing or not, so that's a totally irresponsible or a bad designing things. Remember it, only these are the three use cases when to configure it. Now, the next thing, the precaution. When you are configuring the BGP, One very important thing about the BGP is it is basically all the manual things. It's not like our EIGRP, OSPF, ISIS, or the RIP. Even the neighborship establishment between the BGP routers will be a manual process. You have to manually configure. Think about a scenario. You are going to work because you know enough about the BGP from here or there, wherever, and you think that let's use the BGP in the internal network. Believe me, in a first go, even you will not be able to provide end-to-end connectivity to all the routers. Why? The reason is BGP is somehow a manual process. You have to manually establish the neighborship. After doing that, even nothing will be said automatically in the BGP. You have to again go and add your networks in the BGP. Then only it will be said with the all routers, those who are running that. So if this is the case, I'm going to do everything manually in my BGP, then why to use the BGP? So that is the reason that in IGP scenario, it is never recommended to use the BGP things. BGP is something where you are going to get a full control. You are going to get a full control on your all the routes, on your neighborship, what information you want, how many prefix you want to receive, all that it's depending on you. For that reason, it is used because when we are running that BGP between suppose the two ISP to ISP, obviously on the international ISPs, you have something like a 4.5 million routes. 4.5 million. Think about it. A normal scenario, a normal router or the any routing protocol like OSPF and all, they will crash. They will not be able to handle that much of routing information. So that is the reason why the BGP is manual, where it depends on you. You have a full control. What prefixes you want from your neighbor, BGP neighbor, how much information you want to share with your another neighbor. That all will be in a manual way. Obviously, that is the reason why the BGP is only the preferred protocol between the ISPs or any two autonomous bodies, so that they can have the full control what they want to share and what they don't want to share. It's not like our OSPF. Once the OSPF neighborship is established, everything whatever in the routing table will be said that, and neighborship will be also established automatically. It's not going to be happen same way in the BGP things. And that is the only reason why it is used between the different autonomous system or between the ISPs. And this is the only routing protocol which can handle more than 1.4 billion millions of routes, not billion, 1.4 million routes, which is there on your internet, right? On the internet, we have something like that, millions of routes. And that can be handled only by the BGP, not any other routing protocol. Second reason, BGP is somehow is not for providing the reachability between the devices or between the networks. It is for basically the traffic control. It is for the traffic control. You having the full control that which way the traffic should go, which way the traffic should come in my network. All the full control you are getting in that. So it is for that. It is not for providing the reachability between the routers or between the devices or the end clients. It's something to have the traffic control. The traffic engineering you can do with the help of BGP, and that is required. And that is the only reason of using the BGP protocol. How the traffic engineering is done in the BGP based on some attributes that we'll see in our BGP attributes class. Right. So that is the reason. Now, one interesting thing that when you are going to run the BGP, the two thing is prerequisite for it. The first thing, the engineer or the network engineer who is going to configure it required to have a full in-depth knowledge. If it is not equipped with that, all the information about the BGP, 110%. That's my promise. You will never be able to solve any problem if there will be any issue in the BGP and will not be able to configure properly according to the requirement of traffic control. So full requirements, full understanding and in-depth knowledge about the BGP is required before going to configure on any device. Second thing, the router must be able to handle that much of BGP routes, something like a 1 million, something like that. I'm not telling that all the time it will be the case, but only in the case when you are connecting with the internet, with the ISPs. ISPs are handling that much of it. So these two prerequisites should be there. One, a better understanding about that BGP, in-depth knowledge by the engineer. And the second, the router where you are configuring should know about these things. All right. If these are the case, then you can configure. On only three cases where I will recommend means most of the time any one is going to recommend about the BGP to configure only in these three scenarios. Apart from that, it is never recommended to configure. Right? Now, let's see the next thing. In BGP, when you are going to configure, suppose there are something like two, three routers like this, and you are going to configure it. In BGP, we have a two type of neighbors, and that will be both will be the manual process. One is called as EBGP, and one is called as IBGP. EBGP means between two different AS or two different companies or two different autonomous systems. If on both the router, my AS number is different, that would be called as a EBGP neighbors between the two different autonomous systems. There is a one requirement in the case when you are establishing the BGP between the two different AS number, which is called as EBGP. They must be directly connected by default. It doesn't mean that if they are not directly connected, they will not establish. But in that case, we need to configure some extra command that we'll see in the coming classes. But by default, they must be directly connected. Only then they will be able to establish the EBGP neighborship between the two different AS numbers. For IBGP, when you are establishing the neighborship between the two routers and they both are using the same AS number, that will be called as a IBGP neighborship. In IBGP neighborship, there is no such restriction. The only requirement is they should be able to reach or make TCP connection. No matter whether they are directly connected or they are maybe 10 hops away from each other. Still in that case, they will be able to establish the IBGP. So only requirement in the case of IBGP, they must be able to ping each other's IP address. And there should be a TCP connection established between them. Right? And this your BGP neighborship, wherever it is established in the case of EBGP or the IBGP, whether it is IBGP or the EBGP, it is basically running over on TCP protocol. On layer 4, TCP protocol it is running. That is must. Like our EIGRP and OSPF, they are directly running over IP protocol. But my BGP protocol is running over TCP on layer 4 protocol. Right? So that's also very much required. And what is the port number which is used? 179. TCP port number 179 is required. So whenever you are going to establish the BGP neighborship between the two routers, you must be very clear that port number 179 is not blocked. Like in the case of IBGP, it's very common. In the case of IBGP, because it is not required that router should be connected to the directly. That maybe in between the two routers, we have a firewall, and the firewall is blocking that 170 TCP port number. So they will never be able to establish that neighborship, IBGP. So make sure that you are IP reachability is there as well as port number 179 TCP is also open or available between that two routers. Then only they can establish the neighborship. First of all, in both the cases, when they will establish the neighborship, there will be always, because they are using the TCP protocol at layer 4, always there will be a TCP three-way handshake. First thing this will be happen. If somehow they are not able to establish the TCP three-way handshake, then your neighborship will never come up. So the first thing, your routers are going to establish a three-way handshake, a TCP, like a sync packet, then sync ACK, and then acknowledgement. These three packets will be exchanged. Once the TCP virtual connection is established, only then a router will start sending BGP packet on that. Remember, it's not something like once I will configure the BGP on my two router, they will start sending the BGP packet. Nothing. First of all, they need to establish a three-way handshake. Once it is established a virtual connection with each other, virtual TCP three-way handshake, only then your first BGP packet will go on, and that packet will be BGP open message. What will be BGP open message? So that's very common, even in the case of production network, those who are working. What they do when they are checking the BGP neighborship, they see that BGP is down, but because they are not aware about this, how, why, and what is the reason behind it down, they just complain about that BGP is down. Only I understand this thing. So always make sure anytime when you see that your BGP neighborship is down, first of all, check that whether you are able to ping your neighbor or not. If there is a no layer 3 reachability, obviously there will be no layer 3 TCP connection at all, three-way handshake. So the first thing you need to make sure that both the router are able to ping each other's IP address. Anytime when you are troubleshooting your BGP neighbors. Otherwise, that's not going to make any sense to go and check all the things in the BGP. What you are going to do? If ping is not working, nothing will happen with your BGP neighborship at all. That's a must. Right. So always check that if your ping is working. The second problem you may face about that your TCP port number 179 is blocked somehow between the routers. Right. So that should be very clear about that. Now, what is the reason why in the case of eBGP, they must be directly connected? The reason is any BGP packet that you are going to share, the open message, the first message you are going to share between the two routers, they will always have the TTL value in that set as a 1. Time to live field in the IP header will be set as a 1 because it is a TCP packet. So there will be an IP header also. In IP header, what you are going to mention? The TTL value. And this TTL value in the case of eBGP will be by default as a 1. So it must be required that they should be able to connect directly. But in the case of our IBGP, this TTL value by default is 255. So no problem. Even the two routers are 250 hoops away, still they will be able to make a IBGP neighborship with each other. There will be no such problem. But this is the default behavior. If you want to check that, change that behavior, you can change that. Sometime maybe in the case of eBGP, suppose I want to configure eBGP between these two routers, and the requirement is there are maybe something like a 2-3 interfaces between these, like this, 2 or more than that 2. So what is suggested that a best way to configure the eBGP on the loopback, right? On the loopback IP, the virtual IP. Instead of using my physical interface IP, use it the loopback. So the problem is even with the loopback, you cannot establish your eBGP because that will add a one extra hop by the loopback IP. So to solve that problem, we'll see how we can increase that TTL value by maybe the 2, maybe the 3. It depends on the requirement. So in that scenario, when we have something like this case, we have a 2-3 interfaces and all that. Instead of configuring my BGP 3 neighborship or the 4 neighborship, we can configure the BGP, eBGP on the loopback IP. In that case, we need to change that TTL value on that. Right? So this is about your eBGP and IBGP things. Any doubt till now, you can ask. Otherwise, I will show you the state that what happened once you configure the BGP commands. Let me show you here. How to configure these things? That's not my motto to tell you here what command you need to type. Whatever the AS number of your router is having, you will write that. And very interesting thing. In the case of BGP, you can only run one BGP process. It's not like our OSPF and EIGRP, where you can run many instances of OSPF by using the process ID, by using the AS number of the EIGRP. In case of BGP, you can configure only one BGP instance, not more than that. After that, I need to configure, as I told you, that everything in your BGP is a manual process. So you need to tell who is my neighbor and what is the IP of that, the physical interface IP or the loopback, it depending on you. So suppose that IP is this, 1.1. Maybe the one. And then you will write that what is the remote AS of your neighbor, something like maybe 100, this way. And same way, I need to type on second on my neighbor side, the same command. Once I will type that, what both the router will do, they will establish a TCP three-way handshake with each other, first of all. Once the TCP handshake is done, a virtual TCP connection is done, the router will start exchanging BGP packet. What is that BGP packet? The open message will be the first BGP packet. So let's see that what will be the stages of my neighborship once I will configure these two commands on my both the routers, this side as well as on this side. Obviously, the first thing will be the ideal. Once you are going to start with that, your first thing will be the neighborship will be the ideal, like that. Somehow it is changed. Yeah, it will be in the ideal state. Once you will configure the command, it will go into instantly into the connect mode. And the connect state means your BGP is waiting for the TCP three-way handshake to complete, right? Just typing this command is not going to be happens anything. You are going to send the TCP sync packet, then waiting for the TCP acknowledgement packet. Then again, you will send your acknowledgement. Then after exchanging the three packet, this will be done. So in the connect state, you are basically waiting to complete your TCP three-way handshake. Once it is done, once your TCP handshake is done, so from the connect state, you will jump on to the fourth step, which is called as a open set. If suppose your TCP is not completing, TCP three-way handshake is not completing, so you will jump onto the third step, which will be the active state, which is very common, active state. So active state is telling you that my TCP connection is somehow was not able to complete between the two neighbors. Active state is telling you. And I'm again going to try the same TCP three-way handshake process with my neighbor. Active means I'm trying again and again to establish my TCP three-way handshake. If somehow, suppose it is failed to do that, your state will go from active to ideal. Otherwise, it will go from connect to the open set. In the open set. Is it clear? Any doubt you can ask. In open sent state, your router is waiting for the open message, BGP open message from the neighbor. From the neighbor, it is waiting for the open message. And in open message, basically what is there? In the open message, when both are exchanging with each other, they are going to check each other's BGP capability. What is my neighbor capable of doing in the BGP? Like there will be a version information, AS information, the hold down timer, BGP identifier. There will be some optional parameter. What support is there? Is it supporting the MPLS VPN things? Is it supporting my IPv6 address family? Is it supporting my extended community kind of a thing? All things, whatever is their capability, will be exchanged between the two router in open set state. They are checking each other's capability and they will agree on that this is the minimum things that we can agree on it, depending on my status and your capability of the BGP. From the open sent, you will go into the open confirm state. in open confirm. In open confirm, once open sent is done, open message is exchanged, they have checked their each other's capability, the state will go into the open confirm. In this open confirm, you are waiting basically for the keep alive message. What is that keep alive? It's simply like a hello packet. Do not confuse with the keep alive word. It's basically the hello packet in the case of BGP. Like in the case of OSPF EIGRP, we have that hello packet every 5 seconds in the 10 second. In the case of our BGP, we have the keep alive messages every 1 minute by default. So they are waiting for the keep alive messages from the neighbor side. After receiving this message, the state will move on to the final stage, which is called as a establish. This will move on to the established state. So what problem you may face, what state you will get in reality, if I talk about from the production point of view, you may see your state is ideal, or you may see your state is active. It is toggling between active and ideal again and again. So you need to understand one thing from this. When your state is going to the active and then going to the ideal, it means what is happening? Your router is not able to establish TCP three-way handshake. TCP three-way handshake. And what is the reason behind it? Only two reasons. Either my neighbors are not reachable to each other's IP address, whatever I typed in the neighbor command, first thing. Second, might be the port number 179. TCP port number 179 is blocked between the two routers because of the access list, because of the firewall, or anything in between the router. So if you are able to see that your state is toggling between these two, ideal and active, you need to concern about the TCP three-way handshake. And the TCP three-way handshake, only two things you need to check. The ping and the port number 179 is open or not. That's it. Otherwise, you will never be see these cases. Open send and open confirm and the established. The final state you will see the established. So more or less, you will only see the three status in the production environment: ideal, active, and established. All that in between the phases wise that you will not be able to see that. Right? So let's talk about one more thing. Then we'll quickly jump on to the lab, and whatever we have discussed so far, we'll see and apply that. Before moving on that toward the lab, let's see some more interesting fact about the BGP, a different type of BGP packets that we are going to exchange with each other. BGP messages. First message, as I told you, that we are going to send the open message, which is basically going to change about the capability, BGP capability between the neighbor and you, the router, that whether they are capable of handling this much or that much. So the open message will be the first things that they are exchanging. After that, there will be a keep alive messages also. That keep alive is your basically a hello packet that you are exchanging with each others. Then you have your update messages, which is very important. Update messages are once the neighborship is established, the both the router will update. In the update message, whatever they have, listen it carefully. In the update message, whatever they have in their BGP table by default. If there is nothing, nothing will be said in the update messages also. Be clear about that. If there is something in my BGP table, will be said with my neighbor in that update message. And where you will keep that network information and all that in a field which is called as a NLRI. Network layer reachability information, NLRI. There is a one field under the bit message where you are going to keep your all the network information which is there by default in your BGP table. If suppose there is a nothing in your BGP table of this router, so this router will send a null, no update to my this neighbor. Nothing will be said. Apart from that, the network layer reachability information, there will be some other information like what are the routes that I'm not using currently. It was there, but it is now history, which is called as a withdraw routes. That information will be also there in your update messages. Apart from that, There will be, because BGP is more or less for the traffic engineering, so there will be information about the attribute. Attributes information also will be there. Some kind of a flag bits also will be there that will be used in the case of notifications. So these are the things that you will see in your update messages. Then another type of the packet or the message that you can exchange between in the BGP protocol, something like a notification message. Basically, the name suggesting you notification message means when you want to notify something to your neighbor, something like there is an error in your header. The packet that you are sending, the BGP packet, there is an error in the header because of the checksum, you know about it. So if there is something like that, you will inform to your neighbor by the notification message. If there is, suppose, open send message is wrong, your open message that you are sending, basically having some problem with that, you will inform with the help of notification message. Or maybe something like your password is wrong between you and your neighbor, your password is wrong. Obviously, you will use that concept. Or you are sending your update message and update message is not received properly to my neighbor. So for that also, you will get send a notification. So that means whatever the error is happening, whatever the problem is happening, you need to inform your neighbor by the notification messages. So these are the basic things, basic messages which are exchanged in the BGP protocol by all the routers. All right. So we'll see that one by one, all that things. And before moving on to the next thing, in the lab, let me see that whether the lab is working or not. Let me go here and check that. See that. Oh, that will be there. Yeah. So today also, I will not configure all the router. Only these 4 router I will use for my BGP configuration and all. So let me go back first before I move on to the next topic. Yep, there is a one question. So let me go on that. Important thing. So whenever you are establishing the eBGP, means with your any other autonomous system or maybe the ISP, it's recommended to use the password to secure your neighborship. So we also configure the password with that. Whatever the password you will say, write that here. It's not a plain. So don't never confuse that I'm typing my password as a Cisco, so I'm going to send this information to my neighbor. And what happened in between, there is a one hacker who is capturing all your packet. So it's not something like that. Even if I'm typing the password as a plain text here, it doesn't mean that it will go as a plain text to my neighbor. It will be always by default as a MD5. It will go as a MD5 hash. I will challenge my neighbor with the MD5 hash. If he having the same password Cisco, so he will be able to generate the same MD5 hash. Otherwise, he will not be able to do that. And you will never make the neighborship with that route. Right? So let's go and quickly see that things. So first of all, I will configure this eBGP between 8 and 10. So let's take the access of 8 as well as 10. And then see. And once it is done, the eBGP and IBGP will go and see that how it can create a problem if your knowledge is half about your BGP. That I will also share it here and show you in the demo. All right, so let's first quickly do that. Let's go here under the 10. There is no configuration at all. No problem, we'll do it. And on the 8, let's check it. Is there any configuration on that or not? It is configured. Let's see that. I have all the interfaces. And if there is any protocol is running, if it is running, I will check that it is EIGRP. So it will be run. I don't concern about that. I'm concerned about that. Let's go quickly on the 10 and then configure that. I will quickly configure my one interface, which is between 8 and 10. That is the only requirement and one loop back. So interface E0/0. This network I'm using between 8 and 10. And one loop back like this. 150.1.10.10. And then the mask I will use 4 times to perfect like this. Right? All thing is done. Let's now go and configure my BGP. So it is router 10. So I will use suppose AS number of 10. So how to do that? Router BGP AS number as a 10. Now, if I want to establish the neighborship with router 8, I need to manually configure. If I type here the network command, that has a different meaning. That has a different meaning in the case of BGP. It is not going, this network command is not going to activate my BGP on this interface. No, the network command here is simply used to advertise that network. Okay, so that is important thing. So let's go and establish the manual neighborship, which is 155.1.108.8. And remote AS will be, suppose router 8 is in AS number, because 8, 4, and 5, I will keep it all them in a 1. So maybe I'm using the number 1, 2. That's it. If I want to configure the password, I may configure the password also, but not now. I will show you after configuring the normal BGP between these two routers. Let's go on my router 8. Configure it here, router BGP 123, here's number, and my neighbor is 155.1.108.10. And what is the remote AS of my neighbor, which is 10. If I type my neighbor command both the side, only then they will be able to establish the neighborship, because it's totally manual. Right? So by default here BGP is configured. Let me check that if this is the case. Router no, router BGP 1, please. Let's delete that. And then I will go and see that router BGP 123. And I believe the mistake was not that BGP was configured, it was the IP address mistake. Because if you are not typing in IPv4 format, your BGP will understand that you are typing a name, and that name will be taken as a peer group. So that I was getting here the problem, right? So let's configure it and then see. We have configured this neighborship on both the side. I will be able to see my neighborship goes as a. It's done here. Let's see that whether I'm getting any root from my neighbor 10 or not. So let's check that. So IP BGP, the BGP table, there is nothing. So IP BGP summary will be used to check your neighborship. So neighborship is good, that we can see it here. 8 is a neighbor with router 10. The version is your 4. And the AS number of my neighbor is 10. I have received the 4 message and I have sent the 4 message also. Then there is a table version of my BGP, which is 1 here. They have agreed on that. There is no packet in the in queue or the out queue. Nothing is waiting. My neighborship is up from the last 14 seconds. Because it is established in the case of Cisco, your state will be blank if your neighborship is established properly. That you can see here, there is a blank. Nothing is there. And the prefix I received from my neighbor 10 is 0. I'm not receiving anything. Nothing. The same way like the neighborship is manual, the network that I want to advertise to my neighbors, it is also manual. By default, nothing will come up. Yeah, if suppose on 10 by default, there is a something in my BGP table. If I go and see it here, if suppose something is there in my BGP table by this command, so IP BGP. I will obviously send it to my 8, but because I don't have anything in my BGP table and I don't have any route as a BGP route, so what I will do that to my router 8? Nothing. So nothing will go to my 8 this time, right? This is very important information to understand each and everything in your neighborship command. What is the IP of your neighbor? What is the version you are using? What is the AS number of your neighbor? How many packets you have exchanged between each others? Is there any packet waiting in the inside queue or the outside queue? It should be always zero in the idle condition. And from how much time your neighborship is up from the last 14 seconds. This time in a production environment should be in a days, not in a minute and hours, right? And then state should be always a blank in the case of Cisco. In some other vendor devices like on Juniper, if I say, or maybe in a Nokia or HP, you will see the state as established also. And then at the last, this is the most important information. How many prefix or the network information I'm receiving from my neighbor 10. So it is 0 right now because by default, nothing will go here, right? Let's now go back to the 10 and advertise my network. Some network I want to share with my neighbor 8. So I will go under my router BGP, which is 10 here, and I will advertise. Here, the network command is used for only one purpose, to advertise your network in the BGP process. So if anything in the BGP process, in the BGP table, will go to the all neighbors. To the 8, if there is suppose one more neighbor, there is one more neighbor, so it will go to the all neighbor. So network command is to advertise your network, whatever you will write here, inject it into the BGP table. If it is in BGP table, will be said with your neighbor also. So what network I will do that? Obviously, my loopback, which is 1.10.10, and the mask information is my 255, 255. Yes. And it will go to my BGP. It will be injected in my BGP table on my router 10 itself. So if I go and see it here, this is there in my BGP table. Next up, because this is my own local route, I have injected in my BGP table in my router. So my next hop will be always as a. But because it is in BGP table, will be said all my BGP routers, BGP neighbors. So 8 this time is going to get the BGP that you can see here. All right, this is the first thing. But there is a one catch in this network command. In this network command, when I was typing, there is a one catch. It doesn't mean that anything if you type here as a network command will go to my neighbor or inject it in my BGP table. No. Let's see that. If I go under my router BGP 10 and I just use a random network, something like 30.30.30.30, and the mask is something like 255, 255, 255. This way. If I type this network command, according to my explanation, it should be also in the BGP table. It should be injected in my BGP table. But if I go and check that, it will not be there. No. Why is it so? So that is the catch. The catch is here that any network that you write here, it will not be injected directly into the BGP table. There is a one mandatory requirement that should be fulfilled. Only then this network will be injected in my BGP table. What is that requirement? The requirement is anytime when I'm typing any network command, that should be present in my routing table of this route. So let's check that, whether I have that route in my routing table or not. So no, I don't have that 30.30.30.0/24. If that route is not in my routing table, so no matter what command I'm typing here as a network, this and masking this, it will never go injected into my BGP table. Nothing will happen. So that you need to always remember this. See, these are the very silly things, but very minute things, but it matter most. Because at the first time when you start working with the BGP in any company, in any production network, these are the things that you are going to deal with. You're not going to configure the first day the configuration or the route reflector, like that kind of a thing, or the traffic engineering. You definitely going to start working with the BGP from this point of view. So these are the things which matter most. So you can see that even after typing this command, nothing is there in my BGP table. Why? Because there is a pre-requirement that this network should be present in my routing table. Only then my BGP will inject this network in the BGP table. So if I now go and check it on my 8, 8 will definitely not going to get this at all. Why? Because my 30 network is not there in the routing table. Why the loopback happened? Because loopback is there. Because my loopback is the connected network and it is in my routing table. So that's why it is going on. Now, one more thing. Because my loopback here in the routing table. So that is why my BGP is injecting that because of the network command. Not that 30. But if somehow, suppose I do a mistake here. Let me do that. If I suppose delete that both this network first. Or delete one by one both that. Then 30. Which is here. Now, suppose by mistake, I know that my loopback is there. But if suppose if I go and type a wrong command, 1.10.0, and then mask if I go and write down this way. Because my network 1.10.10 is there in the routing table of 10. But it has a mask of 32. And what I'm doing here, I'm using a mask of 25, 24. So that is also the wrong, right? This is also a wrong thing. This time also, I will not get anything in my BGP table. So if it is not in the BGP table, it will not go to my neighbor also. So be careful. Even you can see that my routing table is having this network 150.1.10.10. But what is the problem? It having the mask of 32. And what I'm doing here, I'm trying to inject my BGP route by this command, which is not there in my routing table. I have the network 150.1.10.10, but with a mask of 32, not 24. So this is the common mistake, which is done by the engineers or anyone those even are experienced for. So these are the silly things. If you are aware about that, you will never commit such kind of a mistake. So let's go back again and route to BGP 10 and configure that this command in a proper way. Otherwise, it will never go to my neighbor. All right, let's go back to the 8 and then discuss some more things about this interesting. See that what I did till now, I just simply configure a one neighbor say BGP between the 8 and 10. And in that, I explain you a lot of thing about the eBGP and all that. Now I will explain some more thing before moving on. Let's see that. This is the BGP route I'm getting in my BGP table. This is not my routing table. It is my BGP table. My routing table is there. This route is there in the BGP table. Because it is eBGP, so my AD value will be 20. And the metric by default will be the 0 in the case of eBGP. All right. So let's get back to the BGP table. Because in my routing table, I will get a simple route information. But in my BGP table, whenever I'm getting any prefix, I'm getting a lot more information. What is that information? We'll see one by one first. The first information that you can see here, I have a star and then I have a greater than sign. Star, you can see it here. Check it here. Star means it is a valid route. Any route, if my router 8 is getting it from the 10, first of all, it will check the validity, whether it is a valid route or not. If it is a valid, then only it will accept in the BGP table. Otherwise, it will never accept that. Second thing, whether this is the best route. Best route means whether I can install this route in my routing table or not as a BGP route. Listen it carefully again. Whether I am able to install this BGP route in my routing table as the best route. I have no other way to reach on this 10.10 apart from the BGP. then only I will get the sign as a greater than sign. That is called as a best route. It will be 100% in my router table. These are the two pre-information about your, this is not my attribute, this is the information about this particular prefix. Next thing, attribute is starting from here till here. All that are your attributes. What is that? Whenever you will receive, when router 8 is receiving anything from the eBGP neighbor, which is router 10, in that case, always remember the next hop information will be the outgoing interface. So what is my outgoing interface on the 10? Obviously, this E0/0. And what is the IP? 108.10. So whenever eBGP neighbor will get any prefix, no matter you are getting from anywhere else, that your next hop will be fixed. Your neighbor's IP address or the outgoing interface as a next. This is the attribute, a BGP attribute also. This next one. Then I have some other command, like I have a metric, local preference, weight, is path, and origin, like that. Do not worry about that. When I will discuss, when we are going to start with our attribute, one by one, we'll see about these attributes. Right now, I will tell you only about this I, which is a origin type. This I here is telling you that basically this network 1.10.10 was injected in the BGP table by network command, under the BGP configuration. And that's correct. On 10, what I did? On 10, I did this command. So that is the confirmation on the 8. At the end, I. It means this network injected in the BGP table by the network command, that is for sure, 110%. If suppose you are not doing it, you are doing it somehow with a different way, then this I will not be there. There will be a question mark. So to show you that, what I can do here, sorry, I can go under here on R8 or R10, under that neighbor say, I will delete that network command. And in place of that, I will redistribute, because in BGP, you can also redistribute anything. I will redistribute my connected. I will redistribute my connected routes into the table, and then we'll see what will happen. I have to wait because it is trying to resolve this network name to the IP address, which is by default on Cisco devices, it is enabled. On some vendors like on Huawei, I haven't seen that this is enabled, the IP domain name lookup, IP domain lookup. But it's something there which is enabled. So most of the time we disable it in production environment also. All right, let's go and see that. What is happening now? I'm getting these root 1.10.10 as a I, as a question mark, not as a I, because I you will get only when you are using the network command to inject that network into the BGP table. But if you are using some other ways like the redistribution way, then you will get the question mark that I'm getting. So this is the way how you can confirm about these roots prefix in your BGP table. And there is a one more interesting information I'm getting here. Another network also, 155.1.108. Why I'm getting this? Because what I did, I redistributed my connected route. So obviously my router 10 has a two interfaces. One is physical interface and one is loopback. And both are injected because of my redistributed connected command. That's why I'm getting it two things. But there is a one more problem. What is that? Why I'm getting as a R? In place of valid, I'm getting as a R. It is a best route, but the problem is it is a R. What is that R? If you check it here, the code R is for what? It is a RIF failure. RIF failure means it's not an error, it's not a problem, or it's kind of a something you need to worry about. It's a very usual thing, according to the BG. It's not any problematic things, it's not a error or any problem in your network. Simple reason of this RIF failure is my BGP is telling to itself that, hey, I am getting this route as a BGP, but the thing is, I'm not going to install it in my routing table as a best route. Why? Because this is I have another way to reach on this network. How? Because it is my own network, my connected network. Then why I need a BGP route for it, right? If I go and check it my routing table, it is my connected network. It is my connected network 108.024. If it is the case, then why should I need that a BGP route for the same? That is why there is R display. That no, there is a BGP route. I'm getting it from my neighbor, but still because this is already in my router as a connected network, then I will not take it as a BGP route in my routing table. So RIP means that route will not be as a BGP route in the routing table at all. What simply you can understand? RIP failure means that route will not be in routing table as a BGP route. It might be your OSPF, it might be some other way. I don't care about that. But yeah, that will not be available in my routing table as a best route, a BGP best route, right? So this is the next thing about your this information when you are checking that your BGP table. So that is why in the case of BGP, it's important to check your BGP table instead of checking the routing table. Because in routing table, you are not going to get these information. Attribute, the next hop, the best route, the failure, the star value, the origin type, the question mark, and the I, all that. Okay. It's done here. Let's get back to the next route, the 5. What I'm going to do now, I'm going to enable my IBGP between 5 and 8. Let's take the access of it because my 8 is in 123 AS number, I think, right? We'll use that on the 5. I hope, I believe there is an IP configured on this. Yeah. So let's configure the BGP here between 5 and 8 as a IBGP. So for the IBGP, what I need my same AS number. Then only it is possible to configure it, right? So let's get back to this on 5 and configure that router BGP 123 and the neighbor my router 8. I can use either the loopback IP here because there is a TTL value is not a concern. So let's use the loopback if I'm able to reach to each other's loopback. Let me check that because IGP, the EIGRP is already running. So I must be able to get that 8 and on 8, let me check that. I'm running that. So what I'm going to do here, I'm going to establish the IBGP between the router 5 and 8 on the loopback IP instead of using the physical IP. So let's do that. Router BGP 123 and my neighbor will be the loopback IP of router 8, which is 8.8. And remote AS will be also the same, which is 123. Right? That's because anytime when you are going to establish the neighborship on the loopback, you have to mention one more command that you are going to get the BGP packet or send the BGP packet via loopback IP, not the physical IP. Because what is the default behavior of a router or any layer 3 device? Whenever they are generating any packet, they will keep the source IP as the outgoing interface IP. So if suppose in BGP packet, you are sending the source IP as a 155.1.58.5, that will be a problematic. The router 5 and 8 will not be able to establish the neighborhood because you are waiting the reply on the loopback and you are getting a reply on the physical one. So that's very important. Whenever you are configuring your neighborship on the loopback IP, one more command is required. What is that command? That update me all that packages on the loopback 0, which is my 1.8.8.8. That is required. That's it. Let's go on my now 8 and do the same thing. Configure the EBGP router. (150.1.5). Remote is the same. And then update on the loopback. One side it is required, update source loopback. Other side, if you even if you don't configure, that will not get it. I'll configure that. Neighborship is come up between the 5 and 8. In the neighborship, if I go and check that, is there any difference? So IP BGP summary. So at the first, you will not be able to note down any difference in that. See that. The only difference you will be get that by the AS number. That here is my neighbor's AS number is 10, and here my neighbor is the same, which is 123. So by that you will understand this is my IBGP neighbors. Otherwise, there is no such things is there at all. Right? So this is the way how we have established the IBGP neighborship between 5 and 8. Let's check that because on my 8, I have these two routes in my BGP table. So obviously these two routes will be received by the 5 also. So let's go that on 5. I will be able to receive that both the routes. 150.1.10.10 and 108.0/24. But I'm getting it here. But there is a one extra information here, which is totally different from our EBGP route. See that? Here I have no other than these two options, star, R, or greater than sign. But in the case of 5, because it is an IBGP neighborhood, so whatever the route you will get, it will be as an IBGP route. And that will be displayed at the start of I. So this I means not the same, which was here at the end. That I was how it is injected in the BGP table. This I is simply telling you that this is my IBGP route. IBGP route means I'm getting it from my IBGP neighbor, which is router, right? So that's a true. 5 and 8 are IBGP neighbor. So that is why whatever the route you will get from the 8 will be displayed as a I. There is a one more problem. What is that? In this IBGP case, what my router 5 is getting as a next hop? Router 10's IP address as a next hop. Why it is not getting this IP address as a next hop? So there is a catch. In the case of IBGP neighbor, next hop will not be changed. Or it will not be changed. Whatever is the next hop on my 8, the same next hop, see that? The same next hop will be given to my router 5. 8 will not change it. It will send it as it is. That is the important thing here to understand. And if suppose the network between 8 and 10 is not available to 5, then 5 will not be able to get that route as the best route. So that is very important to understand. In the case of IBGP neighborhood, whatever the route, it will send it to the 5. It will not change the next hop. Whatever is that already, same will be given to the 5 also. So what problem you will face if you are not aware this concept? That in the case of IBGP, next hop information in the routes will not change. Let me quickly go on 10 and then I will show you what problem you can face it there. What I will do here, first of all, I will go under my router BGP 10 and I will delete my redistribute connected command. And then I will add my simply that network 1.10.10 and mask 4 times 2.5, 2.5. So my 8 will get a 1. And obviously my 5 will get a 1. So I believe that I type a right command 1.10.10 and the mask is 4.5. I get that. Now 5 is also going to get that 1 only because there is a 1 route in my BGP. And the problem is I'm not getting change my next open information. It is as it is. Right now, there is no problem because of the one reason. Let me go back to the 8, make a 1 changes in my EIGRP also. Then you will be able to see what is the problem. If next hope is not changed, I will tell you. I will go here and I will delete my router EIGRP, which is 10. And then I will configure again router EIGRP10, EIGRP10. And this time I will only enable it toward my internal router. Toward outside word, I don't need that. So 155.1.58.0, 0.0.0.255 like this. And for my loopback, I will use the command this. That's all. That's all. It is there. Because I deleted my this one, maybe the neighborship will go down between 8 and 5, and then it will come back again. So let's check that. Show IP root EIGRP. Getting that. So let's see that. What will be the problem here now? So IP BGP. I'm getting that loop back of 10 as a I means IBGP root. The next hope I'm getting as a this one between 8 and 10 without a 10 cycle address. But there is a one more problem. What is that? This time I'm not getting the sign of greater than. Means it is not on my best route. So if I go and check it my routing table, I will not be able to see this route in my routing table. Why? Because it is not a best route. And why it is not a best route? Do I have any other routing protocol which is providing me the information about this loopback? Let's check that. No way. There is no other routing protocol. So the problem is this. Anytime when your router get the BGP route in the BGP table, it's going to do the recursive lookup. For next home. So once my router A5 will get this route, it will check what is the next home, and it will try to find out, hey, do I have any way to reach on this IP or not? That is called recursive lookup. So let's see that whether router 5 knows about this route or not. No, there is nothing. So because my router 5 don't know how to reach on this next hop IP, so it will not make this route as a best route. And it's very obvious, right? If I not able to reach on the next hop, so why should I install it in my routing table, which is totally unreachable for me, basically. So that is the reason why I am not getting as a best route sign, the greater than sign here in this case. Because every time, whenever you will get anything in the BGP table, you must be able to see a greater than sign. You must always do the recursive lookup for the next hop IP. If you are not able to reach on that next hop IP, you will never accept as a best BGP in the routing table. And that is the reason why I have no route in my BGP table, in my routing table as the BGP. But if I go and check it on the 10, there is no problem. So IP route BGP, I have that. Why? Because I know this is my directly connected network. I know how to reach on that. So how to solve this problem? So that R5 should be also able to reach on that network. How can I provide that information? I can use the two ways to solve this problem. Either I can provide the network information this to my router 5 by maybe advertising that network into my IGP, or maybe I can advertise this network in my BGP also. In both the cases, my router 5 will be able to reach on that IP address, and then I will be good to go to keep this route as a best. So let's use any one method. Maybe I will go on my 8 and under my router BGP 123, I will add my this network between 8 and 10 into the BGP process. Inject it in my BGP process. 1.108.0 and the mask will be 3.5.0. Because my router 8 is originating this route. So when he will share this network to the 5, it will use its own IP address as an next hop, not that of the terminal, right? So let's check that here first in my 8. My next hop is a 0, obviously, because I injected this route in my BGP table. Now, when my 5 will get this route, it will get the next hop IP of the 8 because we have established our neighborship on the loopback. So the loopback IP will be the next hop. And because my router 5 know how to reach on this loopback IP, so this will be now my the best route. The problem is resolved by this way. I'm getting that. Now what do you think? I have this route on my router 5. Will I be able to reach on my this IP address or not from the 5, router number 5? If I ping that IP, quickly write something in the chat box. In the long time, for the last 1 hour, you are all in a mute position, not typing anything in the chat box, not asking anything. Tell me whether I will be able to ping it or not. Quick reply in the chat box. I think it is allowed. You guys can. Alam, Rick, Praveen, anyone, those who want, can write down in the chat box. Will I be able to get that ping or not this time when I will ping it from the 5? Let's check that. Nothing is happening. Now, another concept in the BGP. Whenever you are going to work with the BGP, it is must to have a good understanding about the IP packet flow. How IP packet flow from one router to another router. So here there is a one problem. What is happening when R5 is sending a ping command? So it is using the destination IP 1.10.10. Source IP will be the outgoing interface, which is 155.1.58. Something like that. It will go to the 8. From 8, it will reach to the 10 also. So if I go and enable my debug IP ICMP, and I hope that login is enabled, and let's do that again. Ping it again. We'll see that whether it is reaching on 10 or not. So yeah, this packet is reaching on my router 10. But the problem is the router don't know about this IP, which is the source of 5, which is here, 158.5. And that's why the router is not able to, 10 is not able to reply back to you. So it's very much required to have the both side this information on the routers. Otherwise, it's not going to work this way. Right? So packet flow is very much required. You have to have a good understanding how the packet is flowing. Why, if I have the route, I am not able to ping it from the 5? Because my this network between 5 and 8 is not there. So what I can do now, I can add my this network by this command, router BGP 103, and if I can type, I will go under my network command, and I will add my loopback also of my router 5, 1.5.5, and mask will be 4 times 255. This way. So obviously my loopback will go to the 10 also in a second. So let's go to the 10 and then check that. I'm getting that loopback off 10. There is no problem at all. So now if I ping from the 5 with the source IP as a loopback, I will be able to ping that. I will not use my interface because if I type this command again, I will not be able to. No way. Because in the time when router originate any packet, it will use the outgoing interface as a source IP by default. So this time I will change my source IP as a loopback 0. I'm able to ping that. See that. If I trace route even, we'll be able to complete that bar. With my source IP as a loopback 0, and numeric to complete that in a second. So 5 to 8 and 8 to 10, it is reaching, and I'm able to complete that phase. So that is something which is called as IP packet flow, how the IP packet will go from each routers. Just only getting the route, BGP route in your routing table is not going to ensure that whether you will be able to connect to that device or the network or not. Very, very important information. All right. Let's go back now, configure one more IBGP between 5 and 4, and then see what is going to happen. One more concept we'll see. The only reason of configuring neighborship between 5 and 4 to show you one more interesting point about the IBGP. Because already I have configured the IBGP here. So if I'm configuring here between 4 and 5, obviously I want to tell you some more information about that. Let's see that. What is that concept? Router BGP 123, obviously. Maybe this time I'm going to configure my neighbor by the direct IP, physical IP, or the loopback. It depends. Whenever you will use the loopback IP as a neighbor command, you have to type the command update source loopback so that all your BGP messages will be exchanged between 4 and 5 as a source IP of a loopback address, not the outgoing interface IP. Done here. Let's get back to the 5 and configure it. Because I configured it on the loopback, so let's configure it on the loopback. Okay. On router 4. This one, and then my update source loopback. Update source as a loopback. Done here. Let's see the interesting fact on the 4. Because all these routes are I have on my 5 in the BGP table. So by default, it should be go to the 4 also. My this route 10, my this route, and my this route. We'll see what route is going to my router 4. It's there. No matter how much time I'm going to wait. Till then, let's check that BGP membership also. Membership is good, up. And how many prefix I'm receiving? Only one. Why one? Why not three? On router 5, in my BGP table, I having a 3 BGP networks. Then why the router 4 is getting only one, which is the loopback of 5. And that is also the RIP. Why the RIP? Because this is already I know with the help of EIGRP routing protocol and EIGRP having the less AD value, which is 90, as compared to the IBGP AD value, which is 200. Right? That is why it is not installing it as a best route as a BGP. If I go and check my routing table, I will be able to see that my 5.5 is a EIGRP route with the help of 9, not as a BGP. So that is why it is a R. So don't worry about that. I'm not worried about that. I'm only concerned about why I'm not getting that the loopback of 10. Why I'm not getting the interface between 8 and 10 on my 4. Let's go back again on the 5 and watch it closely. What is the reason behind it? See, the route which has no I, it is said with my router 4 in BGP table. But the route which having I at the starting are not said with my router 4. Why? This is the by default nature of IBGP neighbors. What is that default behavior in IBGP neighborship? Any route which is a IBGP route, which is you can see here, you can never share IBGP route with your another IBGP neighbor. It's by default in your BGP. And that's basically for the loop-free environment in IBGP. Because what is the problem? In the case of internally running the IBGP, because all the router are having the same AS number. Same AS number means 123. So there must be a some way so that it should provide a loop-free environment in the BGP. So because of that reason, any router like a router 5 is getting these two route as a IBGP route. Just to ensure loop-free environment, it will never share with any IBGP neighbor, whether it is R4 or maybe the R2 or R1 or any other route. R5 will never share these IBGP route with any other IBGP neighbor at all. Just to ensure that this is providing a loop-free environment internally in the case when I'm running my BGP internally in my company. The reason is because in the case of my internal BGP, my AS number is same. So it is no loop-free environment. In the case of eBGP, there is no such problem because in eBGP, you will all the time get the AS number. Like here, I'm getting that. So there is no chance that the path will be again rerouted by the AS number 10. There is no such a problem. In the case of eBGP, my AS number is going to track the loop-free environment. Every time when a packet will follow from one to a second AS, second to the third AS, that will be added at the end. Like here, it is added. Always it will be added. At the rightmost corner, the AS number will be of the router who originated this network in the BGP table. At the leftmost corner, whatever the AS number you will have will be the information about your neighbor, your adjacent neighbor. Right now I have just one, so I'm getting it as a one. So that is the problem now. So how can my router 4 get this information about these two routes? Is there a way to resolve this issue? No way. There is no way available to resolve this issue by simply working on my neighbors between 4 and 5. The only option left with me, I need to establish BGP between 4 and 8. Because on 8, if I go on 8, my all that route means my 10.10 and 108. They both are not the IBGP route. They are the eBGP route. So if I establish a neighborship between 8 and 4, then that case, my router 8 will share this information with the 4. There is no problem. So that is the only thing you can do. So there is a problem now. In case of you are internally configuring your IBGP on all the router, you must configure it a full mesh BGP. Each and every router have to have a IBGP with each others. Right now here I have suppose a 9 router. So there will be how many neighborship? 36 neighborship in a full mesh. Then only there will be a full network information to each others. To avoid that full mesh information, full mesh IBGP things, I have a two other options. Route reflector way or the configuration. That you will learn, not now. Route reflector I can configure to avoid, because see, it's really, in case of think about a scenario, internally I am running my IBGP and I have something like 1000 of router. How many neighbors will be there? Something like a 4000, more than 4000 IBGP neighbor. Is it possible? No, impossible. Means from the scalability point of view, it is impossible. You can configure still that 4000 neighborship, but it will not be the scalable solution. So for that reason, we use a route reflector concept or the configuration. That we'll see in the coming classes. But right now, if I want to resolve this problem, I will establish a IBGP between 8 and 4. And doesn't matter whether they are directly connected or not, because IBGP can be established between the two routers if they are able to reach to each other. So let's go and see that. Why I'm doing that? Because on 8, these two routes are available as a EBGP. So when 8 and 4 will become the neighbor, 8 will definitely give it this information to the 4. Let's go back to the configuration on my 8 as well as on my 4 and establish the neighborship. I will establish the neighborship on my loop back. And this is not the recommendation that you need to a mandatory requirement. But most of the time, if you see in a production environment, we are configuring our IBGP on the loopback IP, because which is also required in the case of configuring my MPLS BGP. In that case, if suppose you are configuring it on your physical interface, then your MPLS BGP VPN will not work. So that's a very obvious reason to configure the neighborship between the routers internally or the IBGP on the loopback, right? Let's use the remote AS number. Because it is on the loopback, I need to inform my BGP that I want to send my update packet using loopback IP. Same way, I will go on forward. And you will see that all the thing with whatever I'm doing it here, it is done with the help of my manual process. Neighborship, my network command, and all that. 151.8.8. Remote AS is 123, and my update source as a loopback. If my loopback 4 and 8 are able to reach to each others, they will establish the neighborship. So they have established the neighborship. They are not directly connected. Is it possible in the case of OSPF and EIGRP? No. In any IGP protocol, you can only establish the neighborship between the two routers, those who are directly connected. Or there is a one exception in the case of OSPF and IGP, which is GRE tunnel, that you will also learn in that coming chances. And basically, GRE tunnel is connecting the two routers directly. So except GRE tunnel, you can never establish your OSPF or EIGRP between the two routers if they are not directly connected. But in the case of BGP, it is allowed. So 4 and 8 are also neighbor. If I check my BGP neighborship, 4 is the neighbor with my 5 as well as with the 8. Now, if I go and check my BGP routes, I will be able to see that port. Because 8, when sharing with me 4, it is saying that eBGP route. Because these are the two routes are the eBGP routes. And you are allowed to say the eBGP route with IBGP neighbor, no problem. Only problem, you cannot say the IBGP route with the IBGP neighbor. So 4 is getting that or. What do you think if I go and try to ping? And yeah, before that, if I check my routing table, I will be able to get these two routes as a BGP. But the AD value is different. What is that? It is 200. Why? Because it is an IB. In the case of IBGP, my AD will be always 200. If I now go and ping it from the R4 to my router 10 loop back, because I have that loop back, will I be able to get that ping? No. Obviously, the reason is very obvious reason. My this interface or my loop back is not in the BGP table. So no way my 10 will not be able to send the reply back to me, right? It will not be able to send the reply back. If I want to get the reply, I need to do that. Advertise my loopback or my physical interface. Router BGP, maybe this time physical interface, which is 155.1.45.0. And mask is now. Once this will go, to the 10, obviously the 10 is going to receive it. Why the 10 will be able to receive? Because it is going from 4 to the 8 and 8 to the this. So let's go and see it here. Getting that route. 45 dot something, right? So 4 will be able to now ping it. 100% that loop back, which is, if I trace with that, I will be able to do that. 4 to 5, 5 to 8, 8 to 10. Going on, done. Interesting thing is this. On 4 also, when I'm getting that roots, my next hoop is going to be this. What is that? This is not going to be changed. Still, that is the resistance. Because by default, it is not going to be changed. If you want to change, there is a command by which I can change the information of this. How can I do that? Let's go on the 8 and then see it. In my neighbor command, with my router 5 and as well as my 4, will do with the both. Next hope, self command. So I'm telling my BGP process that whenever I'm going to send any information from the eBGP router to my iBGP neighbor, I will change. I will use my own interface or the loopback as a next hope, not as it is. I'm going to send. Same way with 4 also. That's it. If I go on one by one on 4 and 5, I need to reestablish that because the BGP, these things are a bit slow, might be not updated. Let me first check that. See, it is all that. It's not changing it. So I need to reestablish that neighborship. So what I will do, I will copy type this command clear IP BGP and start. This is a command which I will not recommend to anyone to do it in the production network. It's a very, very hard, I mean, it's very drastic changes you will see in your network. And maybe if you are running BGP with the ISP, you will create an outage of 30 minutes in your network. So never try this command. In virtual environment, it is allowed, no problem. My neighborship will goes down and it will be reestablished. And within a second, I will be able to see that on 5 and 4, they will not get the next hope as it is. They will get the next hope, whatever the 8 is setting and sending it to the 4 and 5. Let's go back on the 5 and check that. I'm not getting anything from the 8. Let's check it. It is there on the 8. GP, I'm receiving that positive. Let's get back to the 5. Getting that. So obviously it will be on the 5. So this time when I'm getting the loopback of 10, what is my next loop? It is change. It is not the network between 8 and 10. What is that? It is the loopback. Because I type the command here on 8 under the neighborship next hop self. So because my neighborship is established on the loopback, so my next hoop is now the loopback on 5 as well as on my router 4 here. Right? Let's see one more interesting thing that will confirm your understanding about the packet flow, IP packet flow. What I will do, I will delete this BGP configuration on my router 5. I don't want to use it. No router BGP. One. It's not going to affect anything on the 4. 4 is still going to get that all information. So IP BGP, I'm still able to manage to get my own as well as the loopback of 10 as well as the network between 5, 8 and 10 also. All is there. And they all are the best route, or if they are the best route, they will be in my routing table also. Same way, if I go on the 10, I will be able to see the network of this 4 and 5 on my 10 side. Nothing will change. I'm getting that 45. This time I want to reply from you guys. Now, if suppose I want to ping to this loopback 1.10.10. R4 knows about this one. R10 also knows about the source IP, which is 45 dot something. Will I get the reply? Will I get the ping this time or not? Give me a quick reply on the chat box. I hope that the chat is allowed. You can type that in the chat box. Because there is a two answer, which is yes or no. Will I get the reply? So there are the chances that 50% you may be the right. So what do you guys think? Is it right or wrong? Or reply? I don't know why you guys are not able to answer that. Doesn't matter even if it's wrong. So this time I will not be able to get the reply. Even I have the root of this on 4. Even I have the root of 45 dot something of between 4 and 5. I will not be able to get that big. See that? What I'm getting? You means it is unreachable. ICMP unreachable message. I'm getting it from the 5. I'm not getting that. Interesting, right? R4 knows about that. R10 also knows about that. This is one. But still, they are not able to reach to each other. So be careful about the BGP protocol. Even you both the sides, source and destination knows about each other. Source and destination, they both know about each other's route. But still, like R4 knows about the loopback of 10, and R10 is also know about the network between the 4 and 5, which is this. They know each other's source and destination. But still, they are not able to ping. Nothing. Now, any person who having the good understanding about the IP packet flow, they can resolve this issue very easily. Those who having no understanding about this IP packet flow, they will fail to solve this problem even they have the good understanding about the BGP. What is the problem here? Simple problem. The problem is obviously when R4 want to reach on this IP, which is 10.10, how he will reach? Let's see that step by step. What is happening? R4 will check the BGP table and see that if I want to reach on this 10.10, I need to send a packet to 1.8.8, which is router 8. So obviously, one thing is clear that I need to send the 10.10 loopback packet to the 8. But think about a scenario. Is it possible for 4 to send the packet directly to the 8 on air? Obviously, the packet need to flow on the wire. So now router will do a recursive lookup on 4. Hey, how can I reach on this next hop, which is 8.8, which is 8.8. He'll find out a route that if I want to reach on this 8.8, I need to send that packet to my this neighbor, which is 45.5. I need to send it there on my 5.5. So what your R4 will do? Router R4 will take simply that packet and send it to the 5. It will simply send it. It will simply send it to the 5. Now, when the packet, because of this recursive lookup on the router 4, reached on the 5, 5 will check when he will receive this packet with the source IP of 155.1.45.4 and the destination IP as a 151.10. When your router 5 will receive this packet, what any router do? Any router is going to do just one thing. He's going to check the destination IP and find out in the routing table. Do I know about this IP or not? 10.10. It has nothing to do with the source IP. All right. So let's go back here and check that. Whether I know about that 10.10 or not. With all that. So I have no information. Because router 5 don't know about the loopback of my router 10. So it simply when receive the packet from the 4 will drop it. That's it. So the packet which is going from 4 is black hole here on the 5. Why? Because 5 is not running any BGP protocol. It's just running one, which is EIGRP. And it don't know about that route of the router 10. And very obvious thing that the packet will flow from hope by hope. Is there any way that if you guys are aware that I can jump my packet from 4 to the 8 directly? There is no such way, right? The packet, IP packet means IP concept is basically the hope by hope. So that is the problem. 4 is able to send it by the recursive lookup to the 5. But because 5 having no information about that 1.10.10, so he's not able to reach. He's not able to send it to the 8. And the packet will get dropped. Packet will be dropped here on router 5. Will never go anywhere else. So there is a no 100% guarantee that if anything you have in your BGP table, it means you will be able to reach on that. It is must that all the router in between the path from 4 to 10, they all must have this BGP configured, IBGP or whether it is EBGP. If this is not the case, like here, I'm not running my BGP on the router 5. I'm not able to uh, get the full reachability from 4 to 10. No way. So for end-to-end connectivity, BGP route is not the only one requirement. Second requirement is there must be all the router in between them running the BGP, or maybe one more option is there. That is called as a MPLS. That you will learn in that BGP MPLS configuration, VPN configuration. So either I need to run BGP on all the router or I need to configure the MPLS technology. I need to use that. One very common confusion amongst the working professional as well as to the learning or those who are learning anything, students, about the MPLS. What the thing MPLS? MPLS because it's a 2.5 technology. It is not checking the IP address. It is using the label. So it basically make my core network a fast switching. Packet of switching is in a fast way. So that's totally illogical and it's a totally useless concept. MPLS is not making my switching of the packet fast because it is a 2.5. It is not checking the IP. MPLS, suppose, yeah, it's true that MPLS is not checking the IP address, but it is checking one thing. What is that? Label. So instead of checking the IP, you are checking the label. So what time you are going to save? So that's a total illogical way, even if it is written in the books, that switching will be fast by the MPLS. No, that is the different use case of the MPLS. You will see that when we'll talk about that MPLS in the BGP VPN configuration. All right, with this, we are going to stop here. I just simply took a one basic example of the BGP use case, where to use that BGP and when to configure it, how to configure the BGP neighborship. Only one statement we took today. What is that? BGP neighborship. Two type of neighborship, IBGP and EBGP. What are the different challenges? What are the different stages in the BGP neighborship? I just try to complete as much I was thinking, right? So this is the way how I'm going to cover each and every topic, whether it is BGP, OSPF, or any other. My job is to make the thing simple. My job is not to configure the BGP in this big topology on the 10 router or maybe on the 20 routers and unnecessarily confuse the student that I know very well. My knowledge is very good. I can configure the BGP on the 20 routers. My job is to make the thing simpler to you guys so that you can get a confidence that yes, now I can understand and I can configure it. So once you will start configuring, obviously you will be able to configure it on 10 router, 100 router, or the thousands of router. If you're step by step, if you go and your all the point is clear about BGP. Otherwise, no matter whatever the practice you are going to do, whatever the troubleshooting classes you are going to do for the BGP, you will never be able to work with the BGP. You will never feel comfortable with that. Because the problem, a lot of time, a student come up with the new demand. Hey, I want to learn the BGP troubleshooting. My troubleshooting is weak. I know about the BGP. I know the commands. I know the concept. Everything is my good. But my troubleshooting is weak. So always remember, troubleshooting is nothing. If your concept is clear, there is no such point that my troubleshooting is weak. If your concept about any topic is clear, you don't need any class, extra class for the troubleshooting. You will be able to handle all that. Like here in this class. Now you don't require any class for the troubleshooting. Why the BGP neighborship is not established, if you know about this things. So that is my job here to do that. And I tried as much as to cover in this 2 hour class. Thank you guys to listening me from the last 2 hours with a full patience. Now, if you have any doubt, any question regarding the class about the payment and all that, admission and all that, you can ask me. My backend team is there. There is in the chat box. Check your chat box. You will be able to see that the phone number is there and the website link is there. You can inquire there. Backend team will 100% reply you. Whatever you want to know about the admission, the fee, the timing, and all that, they will clear. Or if you want to unmute, you can unmute also to ask anything. Backend team is there, that they will be available. I may be disconnected in a 1 or 2 minutes, but in that, if you have any doubt, any questions, you guys can ask. I have no problem. If no doubt, I will stop the class here. Thank you once again. We'll see you in the next class in coming weeks. Right? Till then, bye. Thank you, everyone. Do please check that chat box where is the information about the admission process and all that, and backend team will connect with you guys. Right? All right. Thank you, everyone. I'm leaving this mail.